So in this experiment, we are trying to measure the viscosity of a liquid, and the viscosity of a liquid is basically the resistance of flow of the layers of the liquid. And as we know, liquids move in streams, so that the stream or the layer that's close to a stationary object is stationary, and the fastest layer is the layer in the middle. So in order to measure the resistance of flow between those different layers and each other, we use a viscometer. So in this system, we have a Canon Fensk viscometer, and the use of this one is pretty easy. So we pour our fluid from the left side, from the bigger tube, until it fills the, or half fills the large bulb that we have here. And then we start sucking the fluid up the smaller tube until it reaches this mark, or a little bit above it. So that, and then we let it drop. Once it starts going below this mark, we start recording the time, and it takes until it goes down to the other mark. So this time, when we record it, we go to the table that we have in our lab sheet, and you check here which tube that you used, and this one is the 50 capillary tube, as you see written on it. And then you go to the 50 here, and this is the viscometer constant. So you just multiply this by the time you have, and it will give you the Santi-Stokes, or the viscosity of your liquid. So in order to do that, we're going to use this. You press this valve, and then you empty it out, and then you leave it, and then you add it on top of your tube, and then release so that it starts picking the liquid up until it goes a little bit above the upper line. It's a little bit slow. Once it gets into the capillary, it starts becoming faster. Yes, so you just leave it. So now, once the water starts going down below this, we start recording the time. So start recording now, and then we let the surface of the water go down until it reaches the second mark, and that's it for this experiment.